Okay, so have any of you been able to purchase the textbook already? Have the book? All right, I'm just curious, besides the bookstore, which is just, across the street, where are some of the other locations you've found the book? Is it available on Amazon?
Yeah.
Okay, some folks have got it from Amazon. How much are they charging to rent the book from Amazon? Does anybody know? Not sure? Sometimes you can rent for pretty cheap, but I don't know. Whether to buy it or rent it, it's a toss-up. If you have really good notes, then maybe you don't necessarily have to keep the book, but I still have most of the books from when I was a student. So the main thing I wanted to put on your radar is that in the syllabus that I handed out at the end of class, anybody have that syllabus with them today? So you'll notice the last thing on there is a schedule. And so on the schedule, it identifies which book chapters go along with what topics in the course. And, depending on what your goals are this semester, if your goals are to skate by with a D, then maybe you don't need to worry too much about reading the book. But if your goal is to do better than that, then I'd encourage you to make a habit of not only listening and participating to the lecture, but also you're going to need some independent study as well. Learning obviously is a two-way exercise, and I'm sure Dr. Zatar is just like me, where I'm going to do everything in my power, and he will as well, to help you learn the material. But you've got to also pull the material into your mind. It can't just be the instructor trying to push the material into your mind. So the best way you can do that is get the book and habitually read the content that's associated with what we've done in class. So for example, today we're talking about interest rates, rate of return, effective interest rate, and all of those topics are addressed also in the book. So there's other examples beyond the examples I'll share with you, and just that additional exposure is, for a lot of students, what it's going to take to get into that B or A range. So I'd encourage you to really take this seriously. This is important stuff regardless of your discipline. So buy the book and begin reading it. Okay, so you've had now 2 days to look over the syllabus. Is it okay if I just borrow yours for a second? I just wanted to address a couple of things on here. We're still in the first week of classes, and you can drop a class now and it won't show up on your transcript, but after this week it shows as a withdrawal. So I think Tuesday of next week is when the withdrawal period ends. And so if there's something on the syllabus that you don't want to deal with this semester, or if you feel like you're overloaded already, you can make that change to your schedule now, and then it's not going to follow you along on the transcript. So you'll notice that Dr. Zatar has indicated his office location up on the 3rd floor, his office hours, contact details. So all that information is there along with the book information. So it says the ISBN, which is that code number 978, blah, blah, blah. That's the details you'll need to find the best deal on the book. So, of course, there's a lot of policies in here related to COVID, and I don't want to belabor that, but it also is talking about the objectives and the outcomes of the course. And so there's a table that explains all of the things that we're hoping you'll get out of the course this semester, and then the specific exam that's tied to assessing your performance on those particular items. You'll notice that here in the grading policy, Dr. Zatar has indicated that attendance is worth 15% of your grade. So, I mean, that's just wonderful from your perspective. That's all you have to do is just come here and be in the room, and you're already getting 15% of your grade just for showing up. 20% on assignments, and then the remainder of it is from exams. You'll notice Dr. Zatar's late work policy here is that he doesn't accept late work. That the assignment has to be submitted on the due date or before. And then if you have a university excused absence, then late work can be made up, but then you have to make specific arrangements with the instructor. There's some information here about academic integrity, and you need to read and understand that entire section. I'll just give you my Cliff Notes version of that section. That is, anything you turn in needs to be your work. And so if you turn in a homework assignment, it should be the calculations and the thinking and the structure of the problem solving that came out of your mind. It's not a group effort that you all together sat and talked about the problem and figured out how to solve it. That's not what is outlined in this. It's okay to check your work with another student, and it's all right to see if you have the same answer and look for mistakes if you make a mistake. But ultimately, it's your responsibility to put in the mental energy to figure out the problem, because it's that effort of figuring out the problem that's going to persist in your mind long enough to do well on the exam and to retain the material through your career. So the academic integrity expectations are important. So I'd encourage you to familiarize yourself with that, and if you have follow-up questions, please check with Dr. Zatar. The rest of this is pretty much boilerplate university language having to do with all of the policies that govern the course, except for the last page, that schedule. And the schedule is really useful, thank you, because you can tell on any given day what the lecture topic's going to be. And I don't know whether Dr. Zatar plans to continue recording his lectures in the same way that I do. Probably not. Most instructors don't. And I don't blame them. It's kind of a hassle to do. But if there happens to be a certain topic that you want to follow up with, today's lecture and Tuesday's lecture was posted on YouTube, and so is the previous semesters that I've taught this course. So I think your top priorities is the textbook, coming to class, participating when you're here. But I just wanted to mention that as one additional resource, in addition to all the rest of it, is my previous lectures are on YouTube, and there's other professors who do the same thing. So you can find information on each of those topics online as well. Any questions on the syllabus or the schedule before we start talking about interest rates? Okay. Let's talk about different types of accounts, because the type of interest you're likely to get or pay varies on what sort of an account it is. And so maybe some of you are just now entering the phase of your life where you have independent finances. Maybe when you came to college is when you got your first bank account. That was the case for me. A checking account is the type of account that's used for frequent withdrawals, and typically it doesn't earn any interest. So all of the money you have in your check account it's just sitting there not earning interest, and in fact it's becoming less valuable over time because of inflation. Remember, inflation is this idea that goods and services in the future will be more costly. So any dollar you have that's not earning interest is losing its value, since in the future it won't be able to buy as many things. So don't keep too much in your checking account, and even if it does pay interest, normally the interest rates on checking are so meager that they're insulting, frankly. A savings account is a little bit better. It earns interest, but the difference between a saving and checking account is that a savings account has, in most cases, a limit on the number of transactions per month. My bank says that I can't have more than 6 transactions a month for my savings account, otherwise they will charge me a penalty. And the reason why they limit transactions is they want to use that money for other stuff. They want to turn around and take the money I've deposited and make a loan. And so if I'm taking it in, putting it out, taking it in, putting it out, that makes it more difficult for them to loan the money effectively if all of their depositors are doing that same thing, lots of frequent transactions. The savings account interest rate can vary on a day-to-day basis. There's no fixed contract or guarantee that you'll get a certain interest rate with the savings account. It's variable. Money market accounts are a hybrid between checking and savings accounts. A lot of banks will allow you to write checks against your money market account, but they also offer a higher interest rate. The interest rates are variable and can change any time. But usually there's a higher deposit requirement for a money market account, whereas a savings account, there's no minimum. A lot of money market accounts would require that you have at least $5,000 or $10,000 to open the account, and if it falls below that, then you'd have a fee. So that's why they're able to offer the services of both a checking account and a savings account kind of wrapped up into one, is because of the minimum balance. Now, finally, a certificate of deposit sometimes called a CD, is a fixed rate product, where the bank is promising to pay you an interest rate that won't change over time. So they're saying, as long as you keep this money in here for 2 years, for example, we'll pay you 3.5% interest per year during that period. And so the longer the period, typically the better the interest rate is going to be. And so what that allows the bank to do is, if you're depositing the money and you promise to leave it for a certain period of time, then that's money that they can loan out for things like an auto loan or maybe for a home loan. And it gives them the security of knowing that someone's not going to come in and ask for their money back when they've already got it loaned out somewhere else. So it gives them a long-term supply of capital that they're able to use for loans. So those are some of the different types of accounts that you're likely to have in the coming years as you, if you don't already, as you transition into your working professional career. You'll have just a multiplicity of accounts. And sometimes people get confused by the plastic that's in their wallet. I don't suppose that's so much a problem anymore, but when debit cards first came out, people weren't sure what was the difference between a debit card and a credit card, because they can be used in the same way, and they often are pretty similar looking. They have a code number on the front, a magnetic stripe, a chip. They may have the Visa or MasterCard logo, so there's quite a lot of similarities. But the difference is that a debit card is linked to your checking account, so that when you make a purchase with your debit account, your debit card, it immediately is deducted from your checking account. So you're spending your money with a debit card. In the case of a credit card, you're not spending your money. You are, with each purchase, taking out a revolving loan with the issuer of the credit card, and then you promise to pay back that money. The smart thing to do is to pay back the balance in full every month, and that way you never have to pay a fee, you never have to pay interest. So a credit card can be a useful tool if you just pay in full every month. But if you don't, it can be a trap instead of a tool. It can be something that enslaves you to really astronomically high interest rates that are almost impossible to pay off if you get yourself in too deep. So credit cards are unsecured loans, where, in contrast to an auto loan or a mortgage where the bank could take something back from you if you default, a credit card, they don't have a lot to come into your house and take if you've been buying meals or going on trips. And even if you're purchasing clothes, that's a durable thing, but Chase Bank isn't going to come to your apartment and take your clothes. It's useless to them. They'd have no reason to do that. So part of the reason why interest rates are so high on credit cards is because it's an unsecured loan and it's dangerous for the bank. They don't have any collateral that they could take back. The other reason why the interest rates are so high is because people want immediate gratification and they want to spend more money than they've got, and banks can get away with it. So it's maybe for those two reasons together that interest rate on credit cards are so high. A mortgage loan is money that would be used to purchase a home. It's usually, most people would get a 30-year or, a 30 or 15-year loan, really longer durations. In contrast to that, a home equity loan, sometimes people call it a second mortgage. A home equity loan is when you are borrowing against the principal in your house, or, if you've purchased a home using a mortgage, and let's say you got a 30-year mortgage, and you've been paying on that for 10 years. You still have 20 years of payments left, but some of the house is yours at this point. Of the house's value, if the house is worth $200,000, maybe the bank still is owed $130,000, but maybe $70,000 of that value is yours. That's called your equity. It's the portion of the house that belongs to you. You can take a loan against that equity. And that's what a home equity loan is since there's collateral there, the interest rate is much lower than a credit card loan would be. So sometimes people use home equity loans to pay for home improvements or college tuition for their children or medical bills, because the interest rates are much lower, but you can get a home equity loan that you're able to write checks with. So it can be having the convenience of a revolving account. Any questions so far as we've talked about different types of financial accounts? I don't know for certain, but if Dr. Zatar structures his exams like I do, there's going to be a combination of problem solving and also conceptual / short answer questions. And so the short answer questions are where you're having to define a term or explain a certain phenomenon. And so you may be asked to describe the difference between two different accounts, compare and contrast. So I know engineers and quantitative STEM people, what we really like is to get the calculator out and crunch some numbers, but sometimes it's also important to be able to explain the underlying concept. So I think it's great that so many of you are taking notes today, because this is useful information. So let's talk about a concept. One of the things I do on exams is I show a picture, and I ask the student, explain this picture. I think that's great because if they remember the lecture and understood the concept, then they have no trouble describing the trend. So let me tell you what's going on in this trend. This is a graph that shows someone wanting to take out a loan, how much they have borrowed, and how much interest rate they'd have to pay for that loan. So let's say that it's a business loan, for example. And this business wants to borrow $1 million. They have to pay 10% interest to borrow $1 million. But if they wanted to borrow $2 million, it's still about 10%. But what you can see is that as the cumulative amount borrowed increases, the interest rate is going up. So for instance, if they wanted to borrow $7 million, the bank is charging 15% interest on that loan. So can you speculate here, why would the bank demand a higher interest rate if you want to borrow more money? What would cause them to increase their demand for interest?
The risk that you won't pay it back.
The risk that you won't pay it back. Good. That's right. Do you remember what that risk is called? There was a certain key phrase that I described last time. If you don't pay it back, that's called default. Homer Simpson says default is the two sweetest words in the English language. So the risk that you don't pay it back. So why wouldn't you pay it back? You're the same person as you were when you borrowed $1 million. It's not like your character is any different. So this is for the same company. So think about, like, what if I have my own steel recycling business? If I wanted to borrow $1 million, they were only going to charge me 10. If I borrow $7 million, they want 15. I'm the same guy. Don't they trust me? Why are they more worried about default if I'm taking out a $7 million loan? Why is the risk bigger? Why is the risk of default greater than it was when I had only borrowed $1 million?
That's more money.
What's that?
That's more money, but they're not giving it.
It's more money. So if I borrow more money, what does that do to the payments that I have to make? The payments are going to be bigger. And so there's a bigger probability that whatever revenue I have coming in isn't going to be able to meet those payments. So, like taking this down to a smaller level, I could go out and buy, a Hyundai. That's what I did. I bought a Hyundai, right? I can make the payments on a Hyundai. There's no risk that I'm not going to be able to make the payments on my used Hyundai. But what if I went and bought a Ferrari? Ooh, that'd be more tricky, right? Maybe I could make the payments on that. But then let's say I have a bad month where I've got a cavity in my tooth and my kid wants to go to DC on the middle school field trip, and also my propane tank needs to be refilled this month. So like all these other things happen, and also Marshall lowers salary by 6%, which happened last year. So let's say all those things happen at the same time, then I may default on my Ferrari loan, so that's the risk, default risk. So this is a trend that you're going to revisit later in the semester, and a lot of the behavior of lending institutions has to do with their perception of risk and the probability you may not be able to pay back the loan. Everybody understand that concept? Any questions? So here's how I'd say it in words. As the cumulative amount borrowed increases, the risk goes up of a borrower not being able to repay. That's called default. Since there's more risk, then the lender wants to earn a higher rate of return. Okay, so here's the key. It's not about the duration of the loan. This curve would be the same even if the $1 million loan and the $7 million loan, if they both had a 10-year repayment schedule, this curve would look the same. So it's not just because the bigger loan is going to take longer to pay off. This is independent of that. I mean, that may also be true. And if that was true, if it was going to take longer to pay off the larger loan, then we'd also have interest rate risk, which is a separate risk. The risk that the interest rates may go up and you're stuck with this low interest rate loan that you've made. That's interest rate risk. This is just a reflection of increased probability of default. So whenever an organization starts borrowing a lot of money, you need to get nervous because they may not be able to make those payments. A lot of companies go bankrupt when they do that, when they start borrowing a lot of money. I think Hertz was in the spotlight at the beginning of the pandemic because they had a lot of debt. So they had to sell so many of their cars, like a huge quantity of their inventory they had to sell to cover those loans because they had no revenue coming in at the beginning of the pandemic. Okay, so just in review, a borrower who is taking out a loan has to pay the lender interest to compensate them for a few different effects that are all happening at the same time. The first is the time value of money. And I think you probably heard this phrase 3 or 4 times on Tuesday, the time value of money. Anybody remember what's just kind of like an informal explanation of this phrase? What is the time value of money? What do I mean by that? Go ahead.
Money becomes less valuable in the future.
Very good.
And is that the exact part I was going to add? Part
No, let's hear the rest. Yeah.
Well, I mean, is part 2 just that if you borrow money, you have to pay interest?
Sure.
Okay.
Yeah, interest is in part the fee that you pay to compensate someone for the fact that the money you're giving them back in the future isn't as valuable on a dollar for dollar basis as the money that they gave you in the present. So he has it exactly right. Money in the future isn't as valuable as present money because prices are higher in the future. Okay, so that's what we mean by the time value of money. This is such an important concept. I almost cry when I put a question on the final exam and I say, explain the time value of money. If a student can't answer that, I'm crestfallen. Because that is just, number one, it's not that hard. But number two, it's such an important concept. So the time value of money, this idea that $1 now doesn't have the same value as $1 in 5 years. If you are receiving money in the future, you need more of it to compensate for expenditures made today. Okay. Time value of money is one reason why the lender wants interest. Another reason why is they know that some of the people they give loans to aren't going to pay them back. So, oops, sorry, I said the wrong one. That's default risk, not paying it back. And then the one in the middle here, interest rate risk, is the idea that if you and I have an agreement that I'll loan you $100 and the interest rate is 3%, but then tomorrow maybe the economy goes crazy and loans are, instead of 3%, loans are 6%. I could have taken that $100 and loaned it out to someone else at 6%, but I'm stuck with this low interest rate loan that I've given to you. So in the back of my mind, anytime I make a loan, I'm worried about, but if I make this loan, what if interest rates go up in the future and I've got that opportunity cost of the higher profit loan I could have made. So that's interest rate risk. So these three things together are, broadly speaking, the main factors for why lenders demand interest. And you can kind of get a sense for how much each of those is. Because like default risk is high on a credit card loan, and credit card loans are sometimes like 29%. So more of that 29% has to do with default than it does with interest rate risk, because credit card loans are pretty short duration. Like if you do pay just the minimum balance, I think most credit cards, if they're just taking the minimum balance, you'll pay it off in like 8 years. So 8 years isn't a lifetime, not like a mortgage loan where some of those are 40, 50 years even. So the reason why sometimes people are demanding interest, it can vary depending on the loan type. And here again, I'm offering you the suggestion that you need to be able to explain these ideas, not just hear it and say, yeah, that makes sense, but you need to be able to articulate it in your own words. And really, that's how you know that you understand something, if you can explain it to someone else. Okay, so let's talk about different types of interest. Simple interest is when the interest amount is just based on the principal, and they're pretty uncommon. Simple interest loans, maybe the only time you'd ever have a simple interest loan is if you took it out from your parents. Like if they're being really generous to you, because most of the other organizations and institutions are going to want what's called compounding, which we'll define here in a second. But a simple interest loan, the interest amount, I, is the principal amount, P, multiplied by the number of compounding periods, multiplied by the interest rate per period. So interest rate per period. And the most common period duration is a year. But sometimes interest rate is explained on a monthly basis. You can calculate the interest rate per period on a monthly basis by dividing the annual interest rate by 12, for instance. Okay, so if there was $100,000 was the principal, and it was being loaned for 3 years, so that's N, and the interest rate is 10%, this is a simple loan, then the amount you have to pay at the end of 3 years is simply going to be the interest of $30,000 plus the principal. So the total due would be $130,000. This is just in the case of simple interest. Now, compound interest is a way of squeezing more money out of people who owe it to you. And what compound interest says is, instead of just us making this like looking at the whole problem one time, compound interest says, let's calculate how much you owe me every year, for example, and then at the end of that year, we figure out how much you owe me, and then next year, the amount you owe me includes the interest that has been earned up to that point. So here, you're not paying interest on interest, you're only paying interest on principal. That's what's so simple about it. A simple loan only pays interest on principal, but not on the interest itself. Compound interest says you have to pay the interest on your principal and also on all the accrued interest. So accrued interest means all of the interest from previous years or previous periods up till now. So the interest is compounding over time. Like maybe you could use that word compounding the same way. You could say, oh, my problems are compounding. That means they're getting bigger, they're accumulating. Things are getting worse. If you borrow money, compound interest is, it's really hard. And I've heard somebody say that people who understand compound interest save money. And people who don't understand compound interest borrow money. And that's an oversimplification. But I don't know, there's some truth to it maybe. So let me show you the formula for how you calculate the interest amount in a certain time period. My heart used to go into panic mode when I'd see an equation like this when I was a student, because it just looks complicated. You know, if you got Greek in there, you know, limits, blah, blah, blah. It's really not that complicated. And you'll see that when I apply this formula on the next slide. But in words, what that means is that the interest in a certain year is the principal amount plus all of the previous years of interest. So here in this sigma, the language for that is all of the previous period's interest combined. So those two things added together, multiplied by the interest rate, is how much is due in year T. So let me give you an illustration that I think will clarify how compound interest works.
Could you repeat what you just said?
Yep. So the interest amount that's due in a given time period, so this is like for a certain year. So how much interest you have to pay in a certain year depends on the principal of the loan plus all of the previous year's accumulated interest. So all the years before this year. So that's the sigma part of it, previous year's accumulated interest. You can see it starts at year 1 and it goes through year T minus 1. So if this is year T minus 1 is just saying last year.
Thank you.
Sure. Okay, so let's look at this. We previously had the example of 100,000. Let's take that same quantity, $100,000, and it's a 3-year loan, but this time, instead of just looking at that at the end of the 3 years, we're going to look at it at the end of each individual year. So our periods are 1-year periods, and at the end of each year, we're going to add it up and see where things are. So this is going to be, each individual year is pretty simple math, right? So the total amount that you have to pay at the end of the first year is you owe them the principal that you borrowed and 10% of the principal. So 10,000. So your tab, you can think of it as a tab, you know, like how much you owe them, because you haven't made any payments yet. In this example, it's just the loan is getting bigger and bigger at the end of each period. So you haven't made any payments yet. So at the end of the first year, you owe 110. Okay, now where things go in a different direction is in the second year, because in the second year, the amount of interest that you owe isn't just on the original principal. You have to pay interest on the previous year's balance. And so the previous year's balance, remember, was 110,000. So the interest amount you have to pay this year is 10% of that, which is 11,000. So you can see that's where this word compounding comes into play, because the amount of interest you're paying each year is going to be going up. It's compounding. 10,000 was the fee that you paid in the first year. And in the second year, why is it more? It's because you owed them $110,000. And so in their mind, the loan isn't $100,000, the loan is $110,000. And so you have to pay 10% of the loan amount each year. So the new interest amount is $11,000, and then your tab at the end of the year is $121,000, because we add this year's new interest to the previous balance. Okay, now, if you were good at spotting trends, I bet you could predict what's going to happen in the third year. In the third year, the interest amount is the previous year's balance, so 121,000 multiplied by 10% means that the interest that's due is 12,100, and then at the end of that period, the cumulative amount due is that interest amount just for the previous year plus the balance from the last period. So the cumulative amount is 133,100. Does anybody remember what was the total due in the previous example with simple interest?
130,000.
It was 130,000. So what do you think banks like more? Do you think banks like more simple interest or compound interest? Compound. That's a rhetorical question for sure. They like more money. So they like to compound. And in fact, you remember who's greedy? Credit card companies. The more often you compound, the higher things get. And so credit card companies, they won't do annual compounding. Some of them do monthly compounding. Some of them even do daily compounding, where they're going to calculate your loan balance at the end of each day and charge you interest based on that because it's more money in their pocket. So the frequency of compounding also affects how much you have to pay. It's not just about the nominal interest rate, it's also about the frequency of compounding. Okay, let's pause for a second and do some calculations. I've got an in-class exercise for you I'm going to hand out. So give my voice a break and give your ears a break. So here on the first page is some concept questions. So you get in the habit of thinking about how to address a concept question. So that's the first page. I'll leave these up on the screen in a second here. The second page, problems 2, 3, and 4 are calculations using this formula that's provided. Just reinforcing the F, which is a future amount, P, which is a present amount, I, which is the interest rate as a decimal, and N is the number of periods of compounding. So more practice with those. Okay, so let me hand these out to you. So what we're solving is just the first page and the second page, but we'll talk about some other ideas before you do problem 5. Of course, during the in-class exercise, I'd love it if you're talking to your classmates like, this is the time where you can work together. It's just on the homework where you're turning in the assignment that you need to work individually. But it's great if you want to tackle this one as a group.
Did you mark? I didn't have time to finish with it.
No.
Yeah, that one. It was the last one. You write good things on certificates and deposits. You understand why they would have a higher interest rate than savings account? That's okay. Okay. That's what I have written.
Okay, so we've got a table of interest rates, and this is just the interest rate that the bank is publishing. Sometimes they're paying the interest, and sometimes they're receiving the interest. So for example, a savings account, the bank is paying you the interest. Same with the CD. They're paying you the interest for a CD. These other products, they're receiving the interest because they've made a loan and they're getting back the loan plus the interest. So the savings and CD, you've made a deposit. And that's in part why the rates are lower for those products than for these, is when they have to pay the interest, they don't want to pay very much, and so the rate is low. But when they're receiving interest, they want to get more profits, and so the interest rate is higher. So that's just part of the story, but that is an important part of the story. So here, for part A, let me show you how I had put it. My answer for part A. A CD has a deposit duration specified while a savings account does not. So that has to do with why the savings account earns less than a CD is because the bank can't put your money to as much profitable use if there's a risk you can take it out at any time with a savings account. A CD, on the other hand, gives them more stability, and they like that, so they're willing to pay you a little bit more in a certificate of deposit than they are with a savings account. So does that first part make sense? From their perspective, it's better. So they'll pay you a little bit more interest if you promise to leave it in for a certain period of time. Now the other part of this is, but why is a CD interest rate lower than a mortgage? Well, the mortgage is when the bank is receiving the interest, so it's in their interest to maximize that rate. And of course, there's also duration differences. Most CDs, I think the longest CD is typically 5 years, whereas here the mortgage rates are longer. So there's probably the interest rate risk difference between the two. Okay, part B. Why might the mortgage rate be higher for a 30-year loan compared to a 15-year loan? Anybody feel pretty confident about what they wrote, is willing to share it? Go ahead.
Money 30 years from now is going to be less than money 15 years from now, so they need more money.
Okay, good. Yes, that's right. How I had put it, let's see, this tab. More risk of default, but more importantly, a higher risk of interest rates going out and the bank getting stuck with the low interest payments from an old loan. So interest rate risk. And if the loan is longer, then there's also the possibility that in that second half of the loan, the second 15 years, maybe you'll default then. Although most house defaults happen in like years 2 or 3, it's usually not in the first year that someone defaults on a house loan. And once they get past 4 or 5 years, it's also uncommon. Most mortgage-related defaults are in the second or third year. Okay. Why are auto loan rates higher than a mortgage loan rate? What do you think about that one?
Because they're riskier.
Okay, they are riskier. That's true. In what way?
A house can be taken as collateral easily, and there's not a lot of risk of a house being destroyed, but a car can be wrecked really easily.
That's right. And even if it doesn't wreck, it's losing its value. Whereas home prices are going up, so their collateral is getting more valuable. Every day you drive your car, and even if it's just sitting in your garage, I mean, unless it's like some vintage Mustang or something, most cars are getting less valuable as you own them. So it's all about the collateral. I agree. The way that I put it is worse security. Autos lose valuable and are mobile. They're harder to repossess than a stationary house. They know where to find you if you don't pay your mortgage. You can drive your car down to Florida and change your name, have a new life. I'll probably do that one of these days. Move down to Florida, get some plastic surgery, get a tan. All right, so D, what is it about credit cards that helps to explain the significantly higher rate that is charged? Thoughts there, credit cards? Go ahead.
There's no collateral for a credit card.
Collateral, yep, it's collateral. Credit card is unsecured. You've got nothing to take back. And then I think it's also, they charge what they can get away with, you know. People are willing to pay it, so the bank's just going to take as much as they can. There are some legal limits on like the upper end of interest. But, you know, 30% interest is legal. I think maybe even like 32% is legal. So I don't know why they even bother. Sometimes paycheck loan places, have you heard about that? You know, like Cash Plus or whatever, places where you can go in and get a payday loan. Those often will have even higher effective interest rates than a credit card. You know, you may be paying 80, 90% annual interest at a place like that. So that should be the last place you go to borrow money. Okay, so then these other problems. So I'm going to pause and let you finish up on these. There's definitely some meaty calculations for you to do on problems 2, 3, and 4. Okay, up on the screen I've got the solution to problem 2 if you want to check that. let me just make the comment that on these, you need to be accurate to the nearest penny. So don't round off prematurely. For example, maybe you are tempted to say 1.095 to the third power, like just round that off to 1.31. That's not good enough when we're talking about money. People want accuracy to the nearest penny. They don't want accuracy to the nearest $1,000. Bank could get furious at you if you were playing it fast and loose like that. So what I do here is I write out, 6 or 7 digits, and then I have this dot, dot, dot. What that means is that's shorthand for I had a lot more digits in my calculator that I'm not going to bother writing down, but they were there, and I didn't clear my calculator when I multiplied it by 85,000. So I took all of the precision that was in my calculator, multiplied it by this present value to find the future amount. So later in the semester, you're going to learn how to look up these factors. Like this factor of 1.31293, that was a calculated factor. But in the back of your book, in the appendix, there's all these different factors that are pre-calculated for you for a variety of different interest rates and for a different amount of years. So sometimes they're just like pre-calculated, but they'll only report those to 4 or 5 digits, and so you'll have to round off when you're using those pre-provided factor tables. But here, since we have all of the precision needed, we can be accurate to the nearest penny. Any questions on problem 2? This is the time value of money here. Problem 3. Your uncle will loan you $3,500 if you repay him, $4,250 after 4 years. What is the annual interest rate? So we're solving for I. So you can do this rearranging and taking the fourth root to isolate I. Maybe I'm just a little lazy because I know how to use the solver on my calculator. So I just put the equation into my calculator and solve for I. And it tells me that it's 0.0497. So, there again, there's more digits that I may not necessarily be reporting on the paper. In the case of interest rates, it's customary to report interest rates to the nearest hundredth of a percent. So that's why I said 4.97%. That's just what's most common. Okay, so it's on problem 4 that you should use this log function to isolate n. So just in case you haven't finished that calculation yet, I'll pause for another moment to allow you to finalize problem 4, then we'll look at the solution together. Okay, problem 4. P, the original present value amount, is 1,000. I is 0.0475. F, the amount in the future. Now that's just confusing, right? Because I'm saying the balance now is $13,447. So you'd maybe in your mind be forgiven for thinking, well, that's the present value and this is the past value. But the way these formulas work is that the money that is before the other money is what we call present. So the earlier thing was the $1,000. So even though that's the past, that was the first of the two amounts. So the earlier amount and the later amount. So the earlier amount was 1,000. The later amount was $13,447.01. Anybody solve for n? What did you get if you've solved for n so far? What'd you get? 56 and with a bunch of zeros. That's you're right, and that's intentional. That's why I picked this quantity, is because it would give you exactly 56. So let me show you how you can calculate that. Okay, so we're rearranging this F/P relationship to try and isolate n. And by using the log properties, if you take the log of both sides, that'll take the n from an exponent to being down in front of the log. And then there I can continue the algebraic rearranging to isolate n. So I don't do this all in one step in my calculator. That's a recipe for calculation mistakes. If you try and just type it in and then write the answer without like showing your intermediate steps, it's always worth it to take just a little bit of extra time and show your work on the paper. Because if you make a mistake but you showed your work, like if you had the right idea, you're going to get partial credit. But if you just write the final answer and none of the intermediate steps, then sometimes that's not good enough. So here you can see that I showed the formula that's being used and the substitutions, and then these intermediate, like what is the log of that quantity, what is the log of this quantity. Of course, you already know what ... means. I didn't round off. And in the end, you should get that it's 56 years. And how can you check that? Well, you could just put it back into the equation and like starting with a P of 1,000 and starting with I of 4.75%, you could put in the N of 56 and see if it gives you 13,447. And it will. Any questions about either of these three calculation example problems? All right, let's talk about this last part here. Nominal and effective interest rates. So nominal interest, the way you can think about that, the way to remember it, is not really. Nominal interest means that's not really the interest rate, because when you account for compounding frequency, the effective interest rate will be higher. So a bank may say, well, this is a 16% per year loan and it's compounded quarterly. What they mean is that you have to pay 4% interest per year. So it's not really 16% per year if you're having that compounding, because you'll have to pay interest on top of the interest. So the effective interest rate will be higher if there's intermediate compounding. So effective interest is where you'd calculate the interest rate based on how many periods of compounding there are in a year. And the formula that you'd use for that to distinguish between nominal and effective interest is this equation. Okay, so R is the nominal interest rate per year, and you express it as a decimal. M would be the number of compounding periods per year, and I is the effective interest rate. So on this previous slide, it was saying 16% per year. That's the not really interest rate. That's the fiction of the bank making you like maybe trying to think that it's less than that. So the effective interest rate is 1 plus the rate, 0.16, divided by 4 to the power of 4 minus 1. I hope I've got that right. I just did it from memory. Yes. Okay. So let's see what is the effective interest rate if the nominal, so nominal is 16% per year. Effective is 1.04 to the power of 4 minus 1. So let me get my calculator here. 1.04 to the power of 4 is 1.16985 and more minus 1. So that is 0.16985, or another way to express that is 16.985% interest. So the effective interest rate is, it's basically if you account for the effect of compounding, how much interest are you really paying in a year? If you're having to like do this summary every 3 months on a quarterly basis. There's 4 quarters in a year, so that means every 3 months the interest would be assessed. So here's the formula for that, and that is what you use on the last page. So on this problem, I'd like you to get some practice using that formula. So 24% is the nominal. So this is R. 0.24 is R. And you're going to be calculating I for quarterly compounding. So for quarterly, that means M is 4. Monthly, what is the M for monthly? 12. And for daily compounding, M is 365. All right, so let me pause for a second. We've got just enough time for you to calculate these 3 effective interest rates, and then we'll look at it before we break.
Can we see the slide that broke down the formula again?
Yep. Okay, so here I've calculated, depending if you have 4, 12, or 365 compounding periods, what would be the interest rate for each. It's 12:15. We're out of time for today. It's been a pleasure teaching you. I'll email you a link to my YouTube channel so that you can find these lectures if I went too fast and you needed to go back and look at a certain slide. So you'll be able to find the recorded lecture there. Take care.